Right, so in this video we're going to look at solving quadratics. So we're going to look at first factorising quadratics, then we're going to see what solving a quadratic by factorising means, and then we're going to look at the quadratic formula. So here we're going to start first by just looking at how you factorise a quadratic. So what I like to do if it's your first time is I like to draw this little table, and I'm looking for two numbers that when I multiply them together I get the number at the end, which is positive 20, but when I add them together, I get a positive 10. So that's that number here. So a quadratic is written in ax squared plus bx plus c. Okay, so basically times to get c, but add to get b. So then I would usually tell my students to write down all their multiples just while we practice. So 1 times 25, negative 1 times negative 25. 5 and 5, negative 5, negative 5, because two negatives make a positive. Then if we work down these numbers, 1 add 25 is 26, that's not 10. Negative 1 minus 25 is negative 26, so that's not 10. 5 plus 5 is 10, and the last one is negative 10. So that tells me that these two numbers work for 25 and 10, and that means if I factorise, I'm going to have double brackets, and both of my brackets are going to have x plus 5 in. So x plus 5 and x plus 5. And I can simplify that to x plus 5 squared. So that is just factorising when it comes to quadratics. So again, this next question, I'm going to times to make a negative 60, but when I add them, I get negative 7. So if I write down all my multiples of 60, I'm going to have, you could have 1 and negative 60, you could have negative 1 and 60, and so on, because a negative times a positive is a negative. So you could write them all down, and there's a lot, but then you could have 12 and negative 5, or negative 12 and positive 5. So there's a lot more, but I'm just going to write a couple of them, because once you practice and practice, you start realising how to do it just in your head. So here I can see, if I go down, that the first two don't add to give me negative 7. 12 minus 5 is positive 7. So this one here works. Negative 12 add 5 is negative 7. So my two brackets are x minus 12 and then x plus 5. Right, the next one's a special type of quadratic because we can see that we can square root the x squared and the 64. So what that means is this is called the difference of two squares. So that means that essentially when they had two brackets, when they expanded, the b's cancelled out. So what I mean by that is, if I have two brackets, if I square root both of these numbers, x squared is just x if you square root them, and the square root of 84 is 8. So that means one is plus 8 and one is minus 8. So that means you expand them two brackets, there would be no b's in this equation, and that's called the difference of two squares. Right, this next one's a little bit different, so what I'm going to do is I just need a little bit of space, so I'm going to remove this. So for this question, because a is not 1, in this question it's 2, when I'm looking for my numbers, I want to multiply a and c together. So I'm looking for two numbers that times to give me a c, but when I add them together, I'm going to get b. So 2 times 15 is positive 30, and then b is just 13. So again, you can write 1 and 30, you could write 2 and 15, put some negatives in, but just for the sake of the video, we're going to go straight ahead and say 10 and 3. So 10 add 3, both positive, is 13. So what I do now is I basically rewrite the quadratic and remove 13, and I'm going to put 10 plus 3. Because 10 plus 3 is 13. So I'm making it longer. So I'm going to have 10x plus 3x plus 15. What I'm going to do now is I'm going to split this quadratic into two, and I'm going to factorise them separately, just using basic factorisation. So they both have a 2 in common, they both have an x in common. And then if I open the bracket, inside is x plus 5, because that makes 2x squared plus 10x. Then the second half, 3 is what they have in common, and on the inside is x plus 5. You should notice that they both have the same bracket. So that means one of my answers is x plus 5, and the other answer is what is remaining on the outside, which is 2x plus 3. So that is how you factorize a quadratic when you actually have a number that is not 1 for a. Okay, now what we're going to do is we're going to go and have a look at solving a quadratic. Like, what does that mean? So when it comes to a quadratic, if we think about the graph, we are talking about when y is 0. So that means when it crosses the x-axis. So when you solve a quadratic, you're trying to work out, if you had a quadratic, where does it actually cross the x-axis? So we make the equation equal 0. And there's 3 types of graphs you can have. You can have a graph that has 2 solutions. So you can see this red one, it crosses the x-axis at 2 points. You can see the purple one, it only has 1 solution, so it only touches the x-axis at 1 point. Then there's a possibility you have no solutions, and that means that quadratic would not touch the x-axis. So when we're solving a quadratic, we're trying to work out where does it touch if it touches the x-axis. So if we move on then, I'm going to use the same questions so I don't have to redo them. So the first question, what you do first is you factorize it, which we already know is x plus 5 and x plus 5. Because they're both the same, I know now that I'm only going to have one solution for this question. So if I'm going to multiply these 2 brackets together, if my answer is 0, that means inside one of the brackets, the answer should be 0, because anything multiplied by 0 is 0. So you make the brackets equal 0 separately. And in this question, it's going to be the same. So if you minus 5 from both sides, x is negative 5. So that's how I know I only have one solution, because they're the same. So if I go over to my graph, negative 5, let's say it was here, and then the number, which is c, which is my constant, that lets you know where it crosses the y-axis. So just a little quick sketch, it looks something like that. It only has one solution. Right, the next one, again, we done this answer in the beginning, and it was x minus 12 and x plus 5. So if they equal 0, that means x minus 12 is 0, or x plus 5 is 0. So if I add 12 to both sides, x is 12, or if I minus 5 from both sides, x is negative 5. So on my graph, negative 5, 12, and if I look at my c, it's negative 60. So this is just a quick sketch of what it could look like. So we are finding where it crosses the x-axis. So the next question is the difference of 2 squares. So it was x plus 8 and x minus 8 is 0. So that means x is negative 8 or x is positive 8. And it's going to be a nice line of symmetry with the y-axis, because it's going to go to negative 64, and it'll look something like that. Right, this last question, this one had a couple of extra steps in, but our brackets were x plus 5 and 2x plus 3 is 0. So if x plus 5 is 0, that means x is negative 5, which is about here. The next one, you got to solve it. So 0. So minus 3 from both sides, 2x is negative 3. So that means x, if you divide both sides by 2, is negative 3 over 2, or negative 1.5, which will be about here. And then it's going to cross the y-axis at 15, so it should look something like that. Then there's a possibility that you're going to be asked questions where you don't have to do double brackets to factorize, or you can just solve. So in this question, because it doesn't look like my other quadratics, I'm going to factorize first like I would do normally. So they both have an x in common. So I have a single bracket here. So here, this means they both have to, one of them has to equal 0, either the x or the bracket. So that means x is 0, or x minus 12 is 0. So that's going to give me, if I solve it, my 2 solutions. So x is 0, or x is 12, so it'll look something like that. The next one, I'm going to solve it like I solve equations. So add 12 to both sides. So 9x squared is 12. Divide both sides by 9. So x squared is 12 over 9. So now what I need to do is, to work out what x is I'm going to square root both sides. So that's going to give me plus or minus the square root of 12 over 9, which gives me my two answers. So x is either a positive root 12 over 3, because you can square root the denominator, or negative root 12 over 3. So there's my two answers that I can do on my graph. If we get a quadratic where we cannot factorize, that's when we move on to the quadratic formula, which we can see here. So in this type of question, what we're going to do is you just label your quadratic and then it's simply just substitution. Okay, so if we go to the next slide, first what we're going to do is we are going to label that quadratic. So A is 3, B is negative 8, and C is negative 7. Let me just remove that at the bottom. Okay, so all we're going to do then is substitute it into this formula up here. So I like to put things in a bracket, just so if you put them in the calculator, it works perfectly. So B is negative 8, plus or minus the square root of B squared, which is negative 8 squared, minus 4, and then A is 3, and C is negative 7. And we're going to divide the whole thing by 2 times A, which is 3. So if you put that straight in your calculator, it shouldn't be a problem. But just for the sake of the video, I'm going to simplify it. So negative 8 is positive, plus or minus. Negative 8 squared is 64. And negative 4 times 3 times negative 7 is 84. And then 2 times 3 is 6. Again, if you want to simplify that a little bit further, you're going to have 8 plus or minus. Underneath that square root is 148, and the denominator is 6. So now you need to put this into your calculator, one with a plus and one with a minus. If you put the plus in first, you should get 3.36. So on a graph, 3.36, let's say it's about there. And then you should get x is negative 0.69 if you substitute the negative in, which would be about here. And we can see it's going to cross the the y-axis at negative 7. So just a little sketch of what your graph looks like. So with the quadratic formula, you have to label the quadratic and then use substitution.